Okay, question number 9 from sample assessment paper for the P2 exam, International A-Level. Here we have a question all to do with trigonometry. Okay, and the first part of the question, we have this expression sine 3 theta minus root 3 cosine 3 theta equals 0, and we've got to solve for angles for theta between 0 and pi, the equation, and give our answer in terms of pi. So that means we need to have the calculator in radian mode. Okay, so let's just do that first. Make sure it's in radian mode. It's in degree mode. Shift mode 4 for this calculator. So now it's in radian mode. So okay, just be careful that some people forget. Now, question states. Okay, so we got to solve this. So I'm starting off with sine of 3 theta minus root 3 of cosine 3 theta equals 0. I have to change this so I end up with one ratio. Okay, there's no way I can do anything like have two separate factors or anything like that, where I can say sine 3 theta equals something and cosine 3 theta equals something. There's no factors, there's no product or anything like that. So what I can do is I can do it in different ways, but because it says equals 0, I can see that this is going to help me, because if I, for example, divide everything by cosine 3 theta, this will stay 0, this will become root 3, and this will become tan 3 theta, and I've got one ratio. Okay, so dividing by cosine 3 theta, so using a very important identity, which is tan theta is equal to sine 3 theta, or tan, okay, so using the identity, okay, that tan of an angle, say tan of A is equal to the sine of the same angle over the cosine of the same angle. That's a very important identity. All right, so if I divide by cosine 3 theta, this will become the this is divided by cosine 3 theta, this one divided by cosine 3 theta, so divided the whole equation by cosine 3 theta. This now becomes the tangent of that angle. So this is the tangent of 3 theta. They cancel out here, so you're left with minus root 3 is equal to, well, 0 divided by anything will stay 0. So now I'm left with just one trig ratio, tan 3 theta. So I can say the tangent of 3 theta is equal to root 3. And then I know that this is pi over 3 because we did learn about this, the exact trig ratios. This is root 3, which, well, this is the start of the equilateral triangle. That's when you chop it in half, this becomes 1, and this is by Pythagoras root 3. So which one gives us root 3 as a answer for tangent opposite over adjacent? So this must be the angle. So this angle is the 60 degrees, which is pi over 3, 180 over 3. So I know the answer is, or the beginning of our answer is 3 theta is equal to pi over 3. That's what you get when you do 3 theta is equal to the inverse tan of root 3. Okay, so if you do this in your calculator, inverse tan of the square root of 3 equals, and it will give us pi over 3, a third pi. Okay, so now for the tangent curve, it's really simple. Okay, you have one main angle, and every other angle from there is either 180 degrees, which is pi degrees away, pi radians, okay, more than this angle. So you got pi over 3 plus pi will give you the next time that the angle gives you root 3 as its ratio, and then add another pi will give you the next time. So if you got your tan curve, I'll just show you. I'm just trying to explain this. One of the students has been asking about this. So here you have your tan curve. That's 0, that's 90. Then it repeats that same pattern the whole time. That's, so basically every 180 degrees, these repeat. So for example, if this is root 3 here, okay, then that's pi over 3, and that's 180, or pi in radians more, it's 180 more than that. Okay, and then it just keeps repeating like that, both ways as well. So, that's going to be 180 degrees. So every time the gap between them is 180, even this way. Okay, you're going to have a similar kind of situation this way. All right, so that's 180 less than that. Okay, that's 180 less than that. So every time you have to just add or subtract 180 to get to the other angle, which gives you a ratio of root 3. So in this particular case, we've got to be careful though, because we have to, they were told to get the angles between 0 and pi. Okay, so this says, we're told to get the angles for 0 and pi for theta. This says 3 theta, so we got to change that. So we start off with our 0, come on. We start off with our 0 is less than or equal to theta is less than pi. And then I change this by multiplying it by 3. So I have 3 theta is less than 3 pi and greater than or equal to, well, this stays as 0. 0 times anything is 0. So that means I've got to catch all the angles between 0 and 3 pi, not between 0 and pi, because it says 3 theta. So I've got to think about all the angles up to 3 pi. So I'm going to show you another way as well, just another way, so you can, it's another way to think about it. The unit circle. Okay, the unit circle might help some of you understand. I'm just trying to do things that some of you are used to. Okay, so we know that in the unit circle, okay, it's taken from the graphs basically, that in the first quadrant all 3 ratios are positive: sine, cosine and tangent. That's between 0 and 90 degrees, 0 and pi over 2. The second quadrant, only the sine ratio is positive. That's between pi over 2 and pi. So if you were to see the graph of the sine curve, it would be positive between 0 and pi altogether. And between pi and 180 and 270, which is 3 pi over 2, okay, only the tangent ratio is positive, and between 3 pi over 2 and 2 pi, only the cosine ratio is positive, and that just repeats itself. Okay, so for this one, the tangent ratio is positive in these 2 quadrants, so it makes like a straight line when you try to think about it like this. So the angle that the calculator gave us was this angle, the principal angle, which is pi over 3. And if I want to find the next angle up, I've got to add 180 to that, because it's a straight line. I've got to add pi to that. And if I want to find the next angle in, that gives us the same ratio, I've got to add pi to that answer, and again pi to that answer, and then again pi to that answer. I have to keep adding pi's, and I'll get to the same, the angle which shares the same ratio. And if I want to go backwards, if I want to go to the negative side, if I take away, if I go backwards 180 degrees from pi over 3, so pi over 3 minus 180, I'll reach that line again where it shares the same tan ratio, and again, and again, and again, and so on. So basically, for the tan ratio, okay, to find the other angles, I just have to keep adding pi and subtracting pi. In this case, I can't subtract pi because I can't go below 0. So if I try to go this way, if I try to find the angle is this way, okay, if I do pi over 3 minus pi and try to find out what that angle is, it won't be acceptable because I can't go backwards. Okay, so I have to just keep adding pi to this until I'm out of the range. Now the range is 3 pi. Now, if you think about it out of, as a denominator of 3 pi is the same as 9 pi over 3. So this is our limit. Okay, I can't go backwards because 0 is our limit, and that in the negative direction, which is this way, it's negative. This is positive. Clockwise is negative. Anti-clockwise is positive. So I've got to go up to 9 pi over 3. I can't go more than that. So if I add pi to this, well, that's like 3 pi over 3 plus pi. That's going to give me 4 pi over 3. If you're comfortable with your calculator, you just have to keep adding pi to this, because pi is 180. So I'll add pi to this. It gives me 4 pi over 3. Right, that's within our range. We can go up to 9 pi over 3. Then I've got to add another pi, so that's going to give me 7 pi over 3. Okay, that's still within our range. Okay, so I can add another pi, keep adding pi's. It's going to give me 7 pi over 3 in the range. Now if I add another pi to this, I'm going to get 10 pi over 3. 10 pi over 3 is gone too far. Okay, it's bigger than 9 pi over 3. So you see, if I add another pi, I get 10 pi over 3. That's out of the range that we need. We can only go up to 3 pi. And 10 pi over 3 is more than 3 pi. So now, to get the final answer, we've got all the answers that we need. We're going to just divide all of these by 3. So that'll end up with having a denominator of 9. So you get pi over 9, 4 pi over 9, and 7 pi over 9. I hope that was clear for some of you who will have problems with these trig ratios. But for the tangent curve, it's really easy. The calculator gives you the first answer, and then all the other answers are pi added to the answer, and then pi added to that answer, then pi added to that answer, then pi added to that answer, until you're out of the range. And if you can go into the negative side, you got pi taking it away from the answer, so pi over 3 minus pi, and then that answer minus another pi, and then that answer minus another pi, until you've gone out of the range. So part 2, we have given that 4 sine squared x plus cosine x equals 4 minus k, and k is between 0 and 3. Find cosine x in terms of k. So now let's try to sort this out. Now we got sine squared and we got cosine, and we want to have cosine in the end only. So let's change this using the identity that the sine squared of any angle plus the cosine squared of that same angle equals 1 always. That's an identity. It's always true for any angle, as long as they're the same angle. So I can take the sine squared of an angle and I can replace it with 1 minus cosine squared of that same angle, and they would be the same thing. They'll be equal. So I can take that sine squared x and I can replace it with 1 minus cosine squared x. Then they'll be the same thing. So that's plus cosine x equals 4 minus k. So that looks a bit better because we want to have cosine x in terms of k, not sine x. So now let's just expand this bracket. So you have 4 minus 4 times cosine squared x plus cosine x equals 4 minus k. Now the 4's are going to cancel out, because if I did take away 4 from both sides, I'm going to end up with 4 minus 4 cosine squared x plus the cosine of x equals minus k. And now we got like a quadratic in cosine squared x. So let me just bring everything on one side and make it, so let me make this thing positive. So this is going to become 4 times cosine squared x minus cosine x plus k equals 0. Okay, so that's going to become, oh, actually it's minus k. What am I talking about? Let me do it in no, let's not make a silly mistake. Let me do this in step by step so that we don't make a stupid mistake. So what I'm going to do is first I want to multiply everything by minus 1. So I'll have 4. I'll have 4 cosine squared x minus cosine x equals k. Then I will put this on this side. No, in fact, I'll leave it like that because this is like a quadratic, and I want to solve this quadratic. So I can solve this quadratic by completing the square. I could put minus k equals 0 and then use the quadratic formula. What I'm going to do is I'm going to complete the square here. Okay, and I'm going to say, to make me do less writing, I'm going to say let y be cosine x. Okay, so I can replace this with 4y squared minus y equals k. So to complete the square for this, we're going to get rid of this 4 here by dividing both sides by 4. So y squared minus a quarter y equals k over 4. Then I've got to complete the square. So this is going to become a square bracket minus a half of a quarter is an eighth. So you're going to have y minus an eighth squared, and then I'm going to take away from that the square of 1 over 8, which is 1 over 64. And that's equal to k over 4. Now I've got to add 1 over 64 to both sides. So y minus 1 over 8 squared is equal to, now if I add 64 to both sides, let's make this over 64. This is going to be, I'll just do it in step by step. That's k over 4 plus 1 over 64. Then I can actually combine that into one fraction by making this as 4k over 64, because no, 16k over 64, because 4 times 16, make this over 64, multiply by 16, multiply that by 16, so I have 1. Okay, so now what I can do is I can write this as y minus 1 over 8 squared equals, and making this under one fraction now, as we said, that's going to be 16 times 4 is 64, and that's going to be 16k, that's going to be plus 1. So now I can take the square root of both sides, y minus 1 over 8, I don't need to have the bracket now, y minus 1 over 8 is equal to, now when you've taken the square root of this side, it's going to be either positive or negative, the square root of 16k plus 1 over, the square root of 64 is 8, so then I can add 1/8 to both sides, so that will give us 1 over 8 plus this, so it can be, they have the same denominator, so you can put 1 plus or minus the square root of 16k plus 1 divided by 8, and there we have y in terms of, okay, but remember it was actually cosine x we started with, we said let y equals cosine x, okay, so we have to in the end write cosine x instead of the y, so if you say cosine x is equal to 1 plus or minus the square root of 16k plus 1 all divided by 8, and there we have expressed cosine x in terms of k. Okay, and the reason I changed it to y is I have to keep writing cosine x all the time, and it makes it look familiar for some of you when you're completing the square and stuff like that. Okay, we could have at this stage here, we could have written this as 4y squared minus y minus k equals 0, and then we could have used the quadratic formula, a is 4, b is minus 1, and c is minus k, and we would have got the same thing. Okay, I just wanted to use complete the square, but either of them is perfectly fine. Okay, okay, so next is part b. It says when k equals 3, find the values of x in the range 0 to 360. Now this was the original equation. Now what some students actually did when I set this exam for them earlier this year for some of my students, they actually put k equals 3 into the original equation and then said 4 sine squared x plus cosine x equals 1, and then they went on to solve this equation, you know, by making it quadratic, you know, all that, and then they found the, you know, the answers, which would have got them the marks, but it's like going through all of this whole step again that we did before to get this. So all we need to do really is substitute a k equals 3 into this. We've already done all of those steps. We've already done all that solving. So cosine x is equal to 1 plus or minus the square root of, so 16 times 3 is 48 plus 1 is 49. Right, that's going to give us exact values here. So cosine x is going to be either 1 plus 7, so I'll just write it like this, 1 plus minus 7 over 8. So we can say that cosine x is either 1 plus 7, which is 8 over 8, which is 1, or cosine x is equal to 1 minus 7, which is minus 6 over 8, so minus 6 over 8. So cosine x is minus divided by 2 gives you 3/4. So these are the two values for cosine x. All right. So now I'm going to go through how to solve these equations. I'm going to take my time a little bit because I want to make it clear for some of you who are not clear on this. Okay, just write properly next to here. Cosine x equals minus 3/4. So we've got two solutions that we're going to use, and we have to get all the values between 0 and 360. Between 0 and 360. Okay, that's including 0, not including 360. So it's including 0, but not including 360. Now that might be important here in this question. Yeah, see, the 360 is not included in the answer. So now, let's go and solve this equation now. All right, so cosine x equals 1. Now I'm going to show you the way that I prefer first. Okay, the other thing is we're in degree mode. This is degrees. So we have to make sure the calculator is in degree mode. Okay, so shift mode and 4 for this particular calculator. Every other calculators might be different. Now, the way I prefer is this, is I always do it in this way. So I know that the cosine curve is symmetrical, okay, like this, between 0 and 360. Where's its symmetry? It's like this. It goes like down to 90, to 180, and then up to 360 again. Okay, so this is like 180, this is 0, and this is 360. So this 180 is like the mirror kind of image of both sides. So it's like the line that it's reflected in. So if I want to find another angle which shares the same ratio as this angle here, it's going to be 360 minus that angle. 360 minus this angle will give me the other angle which shares the same ratio. That distance here and that distance there have to be the same because it's symmetrical. So for the cosine curve, the calculator gives you one solution. Okay, I mean, I know the answers for this is going to be just basically 0 degrees and 360 degrees, but we won't include it because cosine x equals 1 at 0, and you can see again at 360. So because it doesn't have equals here, I know the answer is x equals 0 for this, and if it had equals, I'd put also 360. And we can't go backwards because we have to stop at 0. So that's the answer for that particular part of it. Okay, however, okay, I'm just going to show you, if you know, from your calculator, say shift cosine of 0, shift cosine of 1 or 0. Okay, let me just do the step here in between. So if cosine x equals 1, then x is equal to inverse cosine of 1. Okay, and your calculator will give you the answer if you're not sure, and that's going to give you 0. Now the other angle, the other main angle which shares the same cosine ratio as 1 will always be for cosine 360 minus this angle. So it's 360 minus 0. I know it's like, what's he doing? Well, just to show you. So it's 360. Okay, so that's the other angle that shares the same cosine ratio. And then after that, every 360 degrees, after that, the cosine curve repeats every 360 degrees. So 360 degrees above this, and 360 degrees above this, and 360 degrees below this, and 360 degrees below this, those angles will repeat, which give you the same ratio as cosine x equals 1. Okay, that will give you the same ratio of 1. Okay, so basically, if this went up to, say, like, 21,000 or something, you would keep adding 360 until you get to the limit. And if it went down to minus whatever, you would keep subtracting 360 from both of these angles until you get to the limit. Okay, so that's how you do with it. But we're not going to have 360s on our answer because the limit doesn't include 360s, it's just before 360. So from this particular part of our solution, x is 0. Okay, now for cosine x equals minus 3/4, I'm going to put this into my calculator. The calculator will give me one solution. Okay, so if I put that into my calculator, whoops, so wrong calculator. If I put that into my calculator, what comes out, let's move the calculator over here, inverse cosine 3/4. Negative 3/4, sorry, negative 3/4. See that I missed that out? Be careful. Be careful. Negative 3/4. Okay. Now that's going to give me an angle which is. Oh, I'm back in radian mode. How did that happen? It could have been degree mode. Okay, so press equals again. That gives me 138.590. So I'll write it like that. That's 138.590. And why does it give me an angle like this? Well, that's because the cosine curve, okay, is negative. If you look at this, we just drew the cosine curve. The cosine curve is negative after 90 degrees. All right, so if we want to find where the ratio is minus 3/4, it's going to be somewhere after 90 degrees. The first angle is going to be there. Now the next angle is going to be over here, which, because symmetry, is 360 minus this. So for cosine, all you have to remember is whatever angle you get, to find the other angle, the other main angle, you do 360 minus what you got, and that gives you the other main angle, I call it. So that's 221.4096. 221.409. I'll just keep it like that. Okay. Now, those are the two angles, okay, between 0 and 360, which satisfy this equation, cosine x equals minus 3/4. All right. If the limit was further and less than this as well, we would then have to take these two main angles and use the fact that the cosine curve repeats itself every 360 degrees. So 360 degrees more than this angle. All right, you add 360 to this, you get the next time where this is true. And you add another 360 to that, you get the next time where this is true. And add another 360 to that, and you get the next time where this is true. You take away 360 from this, you'll get the time before this that this was true. Because it repeats itself, this same pattern repeats every 360 degrees. So you want to find all the values before, you keep subtracting 360 from your answers. Same here, you want to find the next place where this is going to give you the same cosine ratio as -3/4. You add 360, then to that you add 360, then to that you always add 360s once you've got the main two angles. So to find the first angle, you use your calculator. To find the second main angle, you do 360 minus that answer. And then to find all the other solutions, you just keep adding 360s to these until you're out of the range. Now, if we add 360 to these or take away 360s from these, we're going to be out of the range. So these are the only two solutions. So in total, we have the solutions 0 and 138.59. And we're going to give the answer to, I think, one decimal place. It doesn't tell us. So yeah, angles generally should be one decimal place. So that should be 138.6. Okay, 138.6 and 221.4 degrees. 0.4 degrees. All right. Now that's for cosine. That's the answer to this question. All right. So basically, I'm just going to go through a quick summary at the end, especially for one of the students, Fawaz, who keeps asking about this. Now, for the tan curve, that's the simplest. Okay, when you got tan x, basically you get your calculator answer. Sorry, my pen's missing out. Tan x, you get your calculator answer. All right, and then you just add and subtract 180 if it's in degrees, or pi if it's in radians. Okay, you keep adding and subtracting 180 or pi, okay, to the answer to get all the other answers. The tan curve is the simplest. You just calculate, gives you one answer. That one answer, there's one main answer. You keep adding 180 if it's in degrees, subtracting 180 until you've gone out of the range, okay, that you need. Okay, for the sine curve, okay, which we didn't look at yet in this particular example, you get your calculator answer. Now the sine curve, that gives you one of the main angles. I call it one of the main angles. The sine curve is got a different type of symmetry. It goes like this between 0 and 180. Between 0 and 180 is where you have this kind of symmetry. Right? So it's at 90 degrees. So basically, if I know that this angle, for example, this angle has this sine ratio, there's another angle over here which has the same sine ratio. So the distance here and there is the same. So it's going to be 180 minus this angle, which I'll be able to find the other angle that shares the same sine ratio. So the calculator gives you the answer, and then you do 360. Sorry, not 360. For sine, it's 180. You do 180 minus your calculator answer. Okay, minus your calculator answer. All right, and then this is your first angle, and this is your second angle, and then you keep adding or subtracting again 360, because the sine curve also repeats every 360. Okay, so the tan curve is 1 plus or minus 180 because it repeats every 180. For the sine curve, you add and subtract 360, okay, degrees, or 2 pi if it's in radians. Okay, because it repeats every 360 or 2 pi. So from both of these angles, you subtract 2 pi. So for example, supposing one of the angles is not in the range, you get an angle in your calculator not in the range, you keep that answer in your working, because you might have to add 360 to it and subtract 360 from it, and those might generate angles that are in the range. You don't ignore it if it's outside the range until at the end when you write your final answer down. Okay, and for sine, because it's symmetrical about 180 degrees, so it's like it has this kind of shape for the cosine. For cosine x, okay, because it has this type of shape like this, it starts from here, from 0, it goes down, 90, minus 1, 180, 270, 0. You can see symmetrical between 0 and 360. Okay, halfway between them is where the line of symmetry is. So for example, if I know that this angle has this cosine ratio, there's another angle over here that shares the same cosine ratio, this distance is the same as that. So the first angle you get from your calculator, okay, the first angle you get from your calculator, and then you do, for the second angle, the second main angle, you do 360 minus your calculator answer. Okay, that's the second main angle. And then from here, to find all the other solutions, because again, this also repeats every 360 degrees, you add and subtract 360 if it's in degrees, or 2 pi if it's in radians, until you're out of your given range. Same here, you add and subtract 360 to this angle, and from this angle, or 2 pi if it's, you know, this is, of course, this is going to be pi, okay, and this is going to be pi, this is going to be 2 pi as well if it's in radians, okay, and you keep adding that 360 degrees, subtracting 360 degrees until you are outside of the range. And again, if any of this, for example, this calculator answer might be outside of your range, but what's generated from it by adding 360 or subtracting 360 might bring the answer that it generates within the range. So don't ignore it if it's outside of the range at the beginning. At the end, when you write your answers down, then you don't include it. Okay, so that's a little summary of how to deal with tan, sine, and cosine trig equations. Okay, I hope that was clear.